And this is the formulation for confidence interval, and CA is the confidence interval, and X dash is a sample mean, Z subscript C is the Z value for the confidence interval, and S is the sample standard deviation, and N is the number of elements in the sample, and the caps N is the number of elements in the population. This is the formulation that you should be knowing for finding confidence interval. And prediction interval. Prediction interval is a type of confidence interval used in predictions of the regression analysis. So it is the range of value that predicts the value of new observation based on the existing model. For example, just a minute. Let us imagine that the range of value for black grapes is between 0 to 100. So what is the prediction interval here? This is confidence interval. If it is between 0 to 100, the statement that says that the value of a grape, black grape, between 0 to 100 is the confidence interval. But if a test variable comes in, if it is fitting in 1/10th place or 1/20th place, what happens? Then the gap is known as prediction interval. Then the prediction interval is 10 because it is 10 units away from the confidence interval. You got it, guys. What is the difference between a confidence interval and the prediction interval? Yes or no? Confidence interval is a threshold between 0 to 100 for black grape. If the threshold is 110, it doesn't suit in the confidence interval. Then the prediction interval is 10 because it differs from the confidence interval by 10 units. And this is the formulation for prediction interval. We measure it using mean square error, MSE. And residual error, what I told you, it is a cumulative error from of all the data point to the line segment. That means the data point here and the line segment, the data point here and the line segment, the data point here and the line segment. It is a vertical distance between all the data points and the line segment. Where is the miss? For example, can you tell what is the error between this data point and the line segment? The error is nil because the data is getting exactly fitted on the line segment. Got it, guys? Yes or no?
Yes, sir. Got it, sir.
Yeah. And t-test, and this tells you how significant the differences between the groups are. How we can tell it by an example? For example, in a timestamp 1, you can get a group of data. In timestamp 2, you can get a group of data. You should know the difference between those two data. Yeah. In timestamp 1, normal people will be studying. In timestamp 2, what to say, diploma people will be coming and studying. So to measure, so the student set are same, but the timestamp varies. And to measure the significant difference between those two groups, we will be using t-test. That you should be knowing, especially this formulation. And F-test is a very important stuff. Why I am pointing this slide is taken from Professor Andrew Ng from Stanford University. So in order to find the statistical difference between two sets, that means the standard deviation of the two data sets. For example, this is data set 1 and data set 2. And imagine that we are plotting it on a Cartesian coordinate system. So on this Cartesian coordinate system, we are finding the mean for data set 1 and mean for data set 2. To know how the mean is getting differed, let us imagine that this is the data set 1 with marks of the students of a normal batch. And this is the data set 2 with marks of a students of lateral entry. So you are finding the class average of this data set 1 and data set 2, and you are measuring the difference. That is F test. And partial F test comes under for stock market and wherever timestamp comes into picture. For timestamp 1, the stock value is here, and for timestamp 2, the stock value is here. Then what is the difference between them? That is the residual sum of squares of fitted model 1 minus the residual sum of squares of fitted model 2. When time varies, what will be the y value or the dependent values, the dependent variable value that we will be seeing in partial F test. And correlation. Correlation, we can say how the data is getting correlated with one another. For example, with respect to the time, the sales is getting increased and then decreased, increased and then decreased. So it says the relationship. What is the relationship between them in numbers? What is the relation between time and this y-axis in numbers? For example, what is the relationship between the online advertising dollars and monthly income? Yes, it is a kind of a linear relation. Yes, we are finding some substantial evidence for a relationship. So we can say that autocorrelation index is high. The autocorrelation index varies from -1 to +1. That means how the variables, dependent and independent variables, are correlated. That we will be studying in autocorrelation index. And that's it, guys. We have covered both linear regression, simple linear regression, and multiple linear regression.